Hey there. So let's dive into something pretty cool today. We're going to look at how you can read an entire story, a whole journey, just from a single line on a graph. Yeah, we're talking about position time graphs. And trust me, by the end of this, you'll be seeing motion everywhere. But first, think about this. How do you actually show something moving without, using a bunch of words? Imagine trying to describe a car race or a planet's orbit. It would take forever. We need a better, cleaner way to tell that story. And believe it or not, the answer is just that, a single line. It's kind of wild, but one line on a graph can tell you everything: where something started, how fast it was going, when it turned around, and where it ended up. So let's learn how to read it. Okay, so here's the official name for our new tool, the position time graph. The best way to think about it is like a special kind of map, but instead of just showing you a location, it shows you an object's exact position at every single moment in time. Now, to read this story, we've got to learn the language first. And the good news is, it's a really simple language. It's all built on the two axes of the graph. It really is this simple. The vertical one, the y-axis, that's your where. It tells you the position or location of the object. The horizontal one, the x-axis, that's your when. It's just a clock ticking along. So every single point on this graph is just a where and a when put together. That's it. That's the foundation for everything. And this is the part that's so powerful. Every single dot on that line isn't just a random point. It's a precise moment. It tells you, at this second, the object was at this exact spot. You can think of the whole line as a movie of the journey, and each point is a single frame from that movie. All right, we know the rules of the road. Now for the fun part, let's start decoding the motion. The different shapes the line can make, flat, slanted, curved, they're like a secret code, and we're about to crack it. So let's start with the simplest story you can tell. The story of not moving at all. How in the world does a graph show something just staying put? Well, here it is. This is our first piece of the code. If you see a perfectly flat, horizontal line, you know exactly what's happening. The object is not moving one bit, it's at rest. Simple as that. And it makes total sense when you think about it, right? As time keeps ticking forward on the horizontal axis, its position on the vertical axis stays exactly the same. No change in position means, well, no movement. Okay, on to the next piece of our code. What if the object is moving? But let's say it's moving super steady, at a constant speed, like a car on cruise control. This is what that looks like, a straight, slanted line. It's not flat anymore, and it's not curved. It's a perfect diagonal. This is the visual signature of something moving at a nice, steady pace. What this really means is that for every second that goes by, the object travels the exact same amount of distance. That's the uniform change part. The motion is predictable and steady, and that's why the line is perfectly straight. Oh, and check this out. We can even tell the direction of the journey. If the line slopes up, the object is moving away from where it started. But if it slopes down, it means the object is on its way back to the beginning. So now we've got not just speed, but direction too. All right, for our last and probably most interesting piece of the code, what happens when things get a little less predictable? What if our object is speeding up or slowing down? Well, the signature for that is a curve. Anytime you see that line start to bend, you know the speed is no longer constant. A curved line means acceleration or deceleration. The steady part of the journey is over. This happens because the object is now covering different amounts of distance every second. The change isn't uniform anymore, it's dynamic. You could say the story just got a plot twist. So there we have it. We've cracked the code. Horizontal line means staying still. A straight slanted line means constant speed. And a curved line means the speed is changing. Now, let's put all our new skills together and read a full story from a more complex graph. Take a look at this one. It's not just one simple motion, it's a whole trip with different parts. We're going to read this thing from beginning to end, piece by piece, using the code we just learned. Okay, let's start at the beginning. See that first section? For the first 5 seconds, the line is totally flat. And we know what that means, right? Our object is just sitting there at rest, maybe waiting for something to happen. And then, boom, the story gets going. The line starts slanting upwards, and it's perfectly straight. So for the next 10 seconds, our object is moving away from its starting point at a steady, constant speed. A nice smooth ride. And how does our story end? Well, look at that last part. The line goes horizontal again. The journey's over, the object has stopped moving, but now it's at a new location where it's just chilling out again. See that? A complete story, a beginning, a middle, and an end. All right, you're a pro at reading these graphs now, so let's flip the script. It's your turn to be the one telling the story. Can you take a journey described in words and turn it into one of these graphs? Here's your challenge. I want you to picture this. First, you stand completely still for 5 seconds. Then, you walk away at a steady pace for 10 seconds. And then, you just stop. What would the graph of your journey look like? Go ahead, try sketching it out. I have a feeling it might look a little familiar. And that really brings us to a final, bigger idea. We just saw how one little line can tell the entire rich story of an object's journey. It kind of makes you wonder, doesn't it? What other incredible stories about our world, our finances, our health are hiding in plain sight, just waiting for us in the lines of a graph?